let's move forward and talk about our next person, Dmitri Mendeleev. So Dmitri Mendeleev, he is the youngest, he's the baby of the family. He's one of 17 kids.
Hi.
He is from a tiny village in Siberia, which is in eastern Russia, North Asia, right? So he is the youngest kid of this massive family. His dad is a school teacher, but when Dmitri Mendeleev is young, his dad loses his eyesight. He goes blind, and then he's fired from his job. And that plunges this family into some pretty intense poverty. So his dad loses his eyesight, immediately loses his job, he's fired, he can't do that work, he's not perceived as being capable of doing that work anymore. And so Dmitri's mom takes over the task of trying to provide for the family. She is from a more middle-class background. Her family were merchants. And so she ends up restarting the family glass factory to try to keep this enormous family afloat. Dmitri is the baby of the family, right? He's the very youngest kid. And his mother loves him very much. He's really smart. It's his mom's dream and his dream for him to be able to go to university, right? She wants him to be able to go to college. But they live in Siberia, in a tiny village. There's not any universities anywhere near where he is. And so if they're gonna get, the family's, the baby of the family into college, they're gonna have to walk across Russia, right? Moscow is in Europe. Siberia is in Asia. He's literally walking across an entire continent, right? He and his mom, he's the baby of the family, so once it's just him, his mom can be okay, we're gonna go do this. She packs up her baby boy, who at this point is, in his teens, gathers all his stuff, and they walk to Moscow to apply at the University of Moscow so that he can get an education and fulfill, his family's dreams for him. And so they walk literally 1,000 miles, right, from Siberia to Moscow, apply to university there, and Dmitri Mendeleev does not get in. He doesn't get in to this university, despite having walked literally across a continent in order to try. But his mom is not to be deterred. She gathers up her son and is okay, Moscow is not the only city in Russia. This is not the only university in Russia. If the University of Moscow won't take you, we're heading to St. Petersburg. And so they walk to St. Petersburg, where they apply to a different university there, and there he is accepted. So take a moment, just appreciate this one amazing mom with her 17 kids, right? And she's got, this is the last one, the youngest one. It's time for him to leave the household. She has dreams for him, and she will not be deterred, right? When her husband lost his eyesight and lost his job, this lady is the person who steps up and takes care of the family, right? Restarts the family glass factory, finds a way to keep them afloat. And when it's time for her baby boy to head off to university, she's willing to walk across a continent. Russia is cold. The idea of walking across Siberia is not a pleasant concept, but she does it. She loves her kid. Yes, Joaquin?
Wait, so after they get rejected in Moscow, they would walk another 1,000?
I think it's not actually. This is a reference to a song by the Proclaimers. But no, they walk 1,000 kilometers, which is about 2,200 miles in total. It's not 1,000 miles between St. Petersburg and Moscow, exactly. All right. So, he goes to university, he studies chemistry, he becomes a chemist. At this point in time, folks have discovered a number of elements, right? So we've had people like the Lavoisiers who have discovered elements like oxygen. There's also a bunch of elements that people have known about since ancient times, right? People have known about a lot of the metals, things like gold, silver, platinum, lead, for thousands of years, right? And we have, at this point in time, 56 elements that people know about. So there are 56 elements that are known. We know a couple of things about them. We know how much mass these elements have, thanks to Dalton, right? Because Dalton gave us that atomic mass unit, this way of comparing the masses of different elements. So we know how heavy each of these elements is relative to one another. And we know something about how these elements react. There is a word that people use to refer to how elements react. They call it valency. At the time, it's thought of as like basically how many hydrogens would you be able to bond with is what sort of one way of thinking about it. They don't quite know what causes it yet. Nowadays, we do know what causes it. We know that valency is referring to how many electrons are on the outermost edge of an atom that are available to bond with things. And it's really just these electrons on the outermost edge that can do a chemical reaction, right? So how many of them are there is really important. But in Dmitri Mendeleev's time, nobody's even discovered the electron yet, right? So people don't know what's causing this. They just know that, you know, there's a set of elements that can bond with like one hydrogen, and a set of elements that can bond with two hydrogens. And all of the elements sort of fall somewhere between 1 and 8 on this valency scale. Yes, 9.
So we've done a lot of science in the past century.
A huge amount, yes.
And he created the periodic table?
Yes. We're going to talk about how. Gabby?
Can I get water?
Yes, you may. All right. So at this point in time, we have 56 elements. We know how heavy each of them is. We know what we call their atomic mass. And we know their valency, which is basically like, hey, what do you react with, right? Certain elements will react with the same set of other things. And so what Dmitri Mendeleev does is he takes every single element that we know about, he writes down information about them on a little card, and he starts playing with these cards, starts moving them around, looking for patterns. And he discovers something really, really interesting. If you line them up by mass, and then you start thinking about, okay, like, think about how heavy these things are, how they behave, you start to see repetitions in their behavior. There's a periodicity to it. When we talk about periods, or things being periodic, what that word means is that there's a cycle after which things repeat. Right? Several of the girls are grinning like, oh yeah, that's where the word comes from. Okay, makes sense. Right? So the time it takes for a pendulum to swing forwards and back, or like think of those inertial balances we used at the beginning. In fact, if you were to measure the time it took for them to swing to one side or the other, you would refer to it as the period of that pendulum, or the period of that oscillation. But there is a repeating pattern. There is a repeating pattern in how these elements behave. And so he arranges them into a table. And in this table, you can see, all the things in a column behave the same, right? They're laid out by mass, but also there's patterns in their behavior. And that means that if you know where in this table something is located, you can predict its properties. Check.
Why did his mom care about any of his other siblings?
Yes, I'm sure that his mom loved all of her kids. He's the very last one though, so it's like for number 16, she can't like leave with them because then you'd be leaving number 17 behind. He's the last one though, so she can afford to like pack up and go with him.
Yeah.
9?
What happened to his mom after they walked to St. Peter?
I don't know. I don't know a lot about her later life. Yossi?
What's valency again? Sorry.
Valency is like how an element how an element reacts. Nowadays we know that what it actually is the number of electrons that are sort of on the outermost edge of an atom available to participate in chemical reactions. But he doesn't know what causes it. He just knows that there's like we can think about there being categories of element based on how they react with stuff.
So he then just created the periodic table.
He creates the periodic table. He arranges these cards until he discovers this pattern. So a thing that's really important to understand about the periodic table, yes, Naya? Yes, you can grab some water. A thing that's important to understand about the periodic table is it's not just a list. It's not just a series of boxes that have information in them. Your location in the table is really, really important. Based on where something is in the table, we can basically tell you everything about an element just based on where it is. And in fact, he's so good at this. He understands the structure of this table he's created so thoroughly that he predicts the discovery of two elements that have not yet been discovered. There's two elements that nobody has found yet. He says someday someone's going to find an element, and this is what it's going to act like, and this is what it's going to look like, and this is how heavy it's going to be. And he's correct. Yeah.
So because he knows the periodic table that he's created so well and all the patterns, he can figure out what elements.
There's like gaps in the table, there's blank spots in the table, and he's able to say, oh, there must be an element that goes in this slot. Right? Something goes here.
Did we find the elements he was talking about yet?
Yeah, absolutely. And he was correct.
Which ones were this?
I want to say gallium, but I'm not 100% sure off the top of my head. I'd have to look at that.
Can we get time to slip on that?
To what? Oh, just sort your notes? Yeah, we're just about done. And is that the last of my slides? I just want to show you, this is roughly what his table looked like with the 56 elements. This has been arranged into a form that's a little bit more familiar to us. But basically there's spots, there's gaps, and he's able to say, oh, well, whatever is here, right, it's got to be, have a mass in a certain range, and so there's got to be something with a mass between like 40 and 47, and it's going to have, behaviors that are a lot like aluminum. He's going to be able to predict its properties.
But why is it not like the pressure top? And why is it someone on the bottom?
Well, at the time, we haven't discovered all the elements yet, right? So he doesn't have a full table. He's only got 56 elements to work
What
with.
does it look like now?
You will see that soon enough.
I just look it up.
You can look
It
here.
kind of looks like a thingy, like a ball. Is it a full rectangle?
But we are going to have a lot. You will become intimately familiar with the periodic table. Don't you worry. We're going to explore that thoroughly during our chemistry unit.
Okay, so then that's two then, right?
Yeah,
Well,
for sure.
kinda-
Pretty critical discussion of number 2 here about elements in the periodic table. All right. We've only got 2 minutes left of class time. You can take these 2 minutes to gather your notes, put them together. He does get a Nobel Prize for this work. Yeah, you can